Lumiker is a company composed of telecommunications and industrial engineers with a long legacy in the electrical sector. During several years, we have investigated fiber optic technologies such as Faraday, Bragg, Brillouin, Raman and Rayleigh. We have developed different patent solutions which allow us to obtain real-time measures of any asset. 3 years ago, we developed CAMOS, a high-voltage cable asset monitoring system, being the first in the world to predict and locate faults by monitoring functional variables. Our products are today operating in TSOs such as EnergyNet and Red Eléctrica Española. We are convinced that our technology can change the paradigm of how a wind turbine generator is censored and monitored to obtain a world-class maintenance. This is a conventional wind turbine maintenance diagram in which the most relevant components are represented. In the first place, we have the sensors. These are the elements which obtain the variables. Then we have the algorithms which process the information datasets, the communication system to transmit the results, the system energy supply, and last but not least, the cloud process to centralize the information and improve the variable correlations. At present, to monitor a complete wind turbine, the sensors are placed at critical locations, which can measure temperature, acceleration, vibrations, and other data. Connected to this, there is normally a LoRaWAN unit installed to send power to the sensors and transmit the information. For such a system, you would need a complete set of sensors, processing units, and power to monitor a complete wind park. This system has the following disadvantages. You need a power supply normally dimensioned for low energy levels, which means that the systems work in an on and off basis. Dataset transmission is a high energy consumer, hence only a reduced dataset is normally processed. This makes it very hard to establish correlations, limiting the cloud process. Moreover, due to the intense use of energy, the communications are normally unidirectional. Hence, the information only flows from the asset to the cloud system, which makes it very hard for the algorithms to be updated or to learn. Another disadvantage is that since conventional sensing equipment is based in electronics, these electronics are normally affected by the hard and adverse ambient conditions in which the wind turbine is working. In turn, the overall life of the system is reduced and operates with failure, increasing the overall maintenance cost. Lumiker has designed a solution using optic sensors based on Bragg technology to monitor wind turbines. Our system is comprised of 3 major elements: a light emitter, which sends light waves regularly, the Bragg sensor at the selected location, and the light receptor, which will analyze the Bragg reflection. A Bragg sensor has a nucleus of fiber optic where some mirror elements are printed, called Bragg sequences. In this way, when a light pulse is emitted, we can obtain a light reflection which behavior is directly related to the Bragg sequence. This sequence is sensitive to changes in temperature, strain, acceleration, vibration, or any other desired variable. There are a lot of COT sensing elements in the market for temperature, strain, pressure, acceleration, or vibrations using Bragg technology. Hence, they are easily accessible. Our system architecture is simple and robust. It consists of substituting conventional sensors with optical sensors based on Bragg technology. The wind park conventional optic fiber routing may be used to connect these sensors with our interrogating equipment, which ensures the light emitting and receiving and the data processing functions. This equipment is installed at substation and can be placed up to 20 kilometers away from the furthest away sensor. All the sensors are connected to the optic fiber routing through a multiplex box, which is also passive, the same as the rest of the system. By this means, all the communications are managed by the optic fiber, not requiring any power supply. What are the advantages of our system? There is no power supply or communication systems involved, since our system is passive. All the equipment and sensors are extremely resistant to adverse meteorological conditions, such as temperature variations, ice, salt, or humidity. The system is also dielectric and is not affected by electromagnetic impacts or lightning strikes. Additionally, no maintenance or access is required again to the wind turbine generator once the sensors are installed, reducing the number of stops and increasing the asset value to the client. On top of this, the communications volume and dataset handling is drastically increased, not being limited by power supply or network coverage. Monitoring is continuous and occurs on a real-time basis. This increments the level of information available to the cloud and allows a bidirectional flow to update all the process algorithms remotely and decrease all the associated maintenance costs, whilst increasing the client capability to define new maintenance and operational strategies. The sensors can also be modified easily to increase their adaptation to any other environmental condition and include additional measurements at towers, transformers, or foundations, being able to monitor other critical equipment on a real-time basis at the same time.